Very good morning, dear students. So, over here, this is the first online class on this topic, that is Newton's law, and subtopic, that is common acceleration systems. Right. So, these video lectures, they are being prepared by Alan faculty who teaches for IIT JEE exam. I hope that these will be useful for the public at large, right? So without further delay, let us go into the basics of this common acceleration systems, right? So therefore, what do we mean by this common acceleration, right? It means that the system of bodies, they have the same magnitude of acceleration. For example, suppose that there is a block over here, let us say, right? And there is one more block over here, let us say, right? Now, if we were to apply a force on this particular block over here, let's say, this is our F force, then this particular system over here, made up of these two blocks, they will be having the same amount of acceleration, right? Whatever is the increase in the velocity of the first block per unit time will also be the same as the increase in the velocity of the second block, because they are always in contact, and therefore they come under this common acceleration system, right? Now suppose that you have a case over here, let us say that this is one block M1, there is a string over here, this is M2, and suppose that we were to apply a force on this particular block over here, let us say some F force. Again, this particular system will have the same magnitude of acceleration, right? In this direction, both will have the same amount. What about this case? This is nothing but an M1 mass. This is nothing but an M2 mass. Do you feel that the acceleration of these two masses are the same? We observe that one of them, if it is heavier, let's say that your M2 is greater than M1. In that case, M2 will be accelerating downwards and M1 will be accelerating upwards. Whatever is the amount by which the M2 moves down, the same amount M1 will move up also, because this string, it cannot break. It is neither it is not extensible. So therefore we say that the magnitude of the acceleration of M1 and M2 both will be the same, because the increase in velocity will be the same, the amount of displacement per unit time will be the same for both of them in magnitude, but opposite in direction, right? So this one also will fall under the category of common acceleration systems, common magnitude of acceleration, right? Let us take another case. Suppose this is your mass M1, there is a string over here which goes over a pulley. This is the other mass, let us say this is some M2 it is, right? Now if we let go of the system, what do you feel will happen? Suppose that the surface over here is nothing but smooth, right? No resistance from the surface. We observe that the M2 will be accelerating downwards. The M1 will also be accelerating, not downwards, it will accelerate to the right side. Whatever is the displacement of M2 down will be the displacement of M1 to the right side. That means the rate of change of position, which is nothing but displacement per unit time, which is nothing but velocity of M1, M2, they'll be the same in magnitude. That increase in the velocity per unit time will also be the same for both. That is your acceleration. So therefore, in this case also you have common acceleration, and all these are common acceleration systems. This way you can construct many such systems. For example, what about this case? Let's say that you have M1, you have M2, and all the surfaces are smooth, let us say, and we let go of the system. Do you feel that both of them will have the same magnitude of acceleration? Yes. This string over here is an inextensible string. It will not allow the velocity to be different along that string. It will not allow the acceleration to be different along that string. So therefore, let us say that the M2 is moving in this direction. Therefore, M1 will be moving up the inclined plane. Right? There are some conditions, and we will check for these. Or how do we find the actual direction of acceleration? Right? So in all of these common acceleration systems, the idea remains the same. You just use the common acceleration as the net pulling force divided by the total mass of the system. Net pulling force divided by the total mass of this. Very, very simple. This is very simple. You can apply it for all these problems. So therefore, let's now write the answer for all of them. We will name this one as the first diagram. This one is second one, third one, fourth one, and fifth one. Right. So therefore, for the first one over here, we observe that what is the net force which is making the system move? Yes, it is not exactly the net pulling force. In the case of strings, etc., and gravity, you will be finding that. In this case, it is nothing but the net force itself which is acting on the system. Now, in between M1 and M2, there is the contact. In between these two, there will be a contact force, but that contact force will not be external, that will be internal to the system made up of these two masses. So when we write your acceleration, that must be the external force. Therefore, the only external force which is making the two masses move is nothing but capital F itself. That is your net force divided by the total mass. Total mass is simply M1 plus M2. Right? In the same way for the second one also. Over here also, the F in this case is the pulling. It is the pulling force. Tension force will become internal to the system. Then whatever is the force which is present among those masses, that will be internal in nature. Therefore, again we can write F divided by M1 plus M2. Very, very simple. Yes. You come to this particular third one. This part is clear. No doubts will be there. On the third one, we observe that due to what force should the M2 move in the downward direction? Someone is there who is pulling the M2. Yes, that is your earth only. So this is your M2G. This one is nothing but your M1G. Right? So in the case of the third one, you can write the acceleration as the net pulling force. Out of these two forces, M2G and M1G, we see that they are competing in nature. This M2G is trying to make the system accelerate this way, whereas the m1g is trying to make the system accelerate the other way. Both of them will not occur, only one of them will occur. So therefore the one which is higher of m1g and m2g, that will decide the direction of acceleration. That's all. So since we have selected m2g to be more than m1g, therefore since m2 is greater than m1, therefore this must also be valid. m2g greater than m1g. So therefore we can write the common acceleration as the net pulling force. Net means in this case the difference, or they are opposing, divided by the total mass of the system, which is m1 plus m2. This part is clear. Fourth one you can predict now. Very easily. Who is responsible for the system's acceleration? Only the force of m2g. m1g is not going to make the system move. That will be balanced by some reaction from the floor. So therefore tension is not going to make the system move. That becomes internal to the system, and tension will not be, it is a, what do you say, it is not, for any system, if tension is there, it is not going to increase or decrease the energy of the system, right? Since they are inextensible strings, they cannot store any energy, right? So in this case directly you can write the acceleration is due to the force of this m2g and m2g only. So therefore that is the net force divided by the total mass, that is m1 plus m2. That's all. That is your answer, right? For the fifth one, we need to go into the components of the force of gravity. So for this vectors are required. So suppose that over here you have a force which is nothing but, let us say, mg, right? We want to split this into two components. If this angle over here is nothing but equal to alpha, then we can say that this angle is 90 degrees, which means that this angle over here will be 90 minus alpha, which means that this angle over here, since the total angle is nothing but equal to 90 degrees over here, out of which this particular angle, if it is 90 minus alpha, this angle is the same as this angle. They are both 90 minus alpha only. This angle will be your alpha itself, right? So if this is your alpha, then in this will be a component of mg, which is mg cos of alpha. This will be pointing perpendicular to the incline and into the incline. The other component is nothing but your sine component, which is mg sine of alpha, right? So once we are, yes, this is something that you have to remember for future also. The moment you have this g, and over here the component of g in this direction down the incline is nothing but equal to g into sine of theta. In a direction perpendicular to this incline, it is g into cos of theta. This you have to remember, right? So therefore coming back to this particular problem, now what are the forces which are acting on these two masses which are going to accelerate the system? In this direction, normal and m1g cos alpha, they will be balanced. This is your component of mg down the plane, that is m1g sin alpha. In this direction, it is m1g cos of alpha. Down the incline, it is the sine component of mg, that you remember. Perpendicular to the incline, it is the cos component of mg, right? Similarly you do for the other mass. down the incline, it is m2g sine of beta angle. Perpendicular to the incline, it is m2g cos of beta. Over here, the normal will balance the cos component, m1g cos alpha. Here also there will be one more normal that will balance the m2g cos beta. The tension from the string becomes an internal to the system. That is not going to increase or decrease the acceleration of the system. Right. So therefore, depending out of these two forces is greater because they are opposing. M2g sine beta wants to make the system accelerate to the right side, whereas m1g sine of alpha wants to make the system accelerate in this way. They are competing forces. Can you tell what will be the acceleration? What will be the expression for acceleration in this case? You think of pause it and you think over it and you check that. We are going to take m2 sine beta greater than m1 sine of alpha. Therefore, we can write, since m2g sine beta therefore will also be greater than m1g sine alpha, therefore the net pulling force will be m2g sine beta minus m1g sine of alpha divided by the total mass m1 plus m2. That's it. This part is clear, gentlemen. That's it for present class. We'll take up such short videos in the upcoming sessions. Yes, thank you for attending. Yes.